So for number 7, we've got the function 6 divided by x squared plus 1. So for your x-intercepts, remember that's when y is 0 and you're finding x. So if we plug in 0 for y, and really what happens is you multiply by that denominator, and what always happens is you always end up solving for your numerator being equal to 0. Because if we do 1 equals 6 over x squared plus 1, if we multiply by x squared plus 1 over 1 on both sides, this cancels out, and anything times 0 on the left is still 0. So we end up with 0 equaling 6. Okay, well that's a false statement. So in this case, normally there'd be an x there to solve for, but in this case there's not. So in this instant, there actually is no x-intercept, which is fine. That just means it never touches or crosses your x-axis. So the y-intercept is the one where you guys plug in 0 for x, and you have to solve for y. So anything that's an x becomes a 0. So y equals 6 over 0 squared plus 1, which equals 6 over 1, which is just 6. So that's all for the y-intercept. The vertical asymptote, that's when you guys set your denominator equal to 0. So your denominator is x squared plus 1, set it equal to 0. So in this case, you guys could try factoring it, or you could actually subtract the 1 over and get x squared equals negative 1. Well, nothing squared is ever going to equal negative 1, and you can't take the square root of a negative. So there's actually no vertical asymptotes either, which is, again, fine. Horizontal asymptote, we're looking at our exponents, and remember guys, fillers, you can always put fillers in here. So you can make this 6 times x to the 0 power. X to the 0 power is just 1, which keeps it as 6 times 1, which is just 6. So if your numerator has a degree of 0 and your denominator has a degree of 2, that means m is less than n because 0 is less than 2. So when that's the case, your horizontal asymptote is at 0. So I just went ahead and graphed this in my calculator and pulled points from my table. So if I put my points here, I'll just make a little table. So 1, 3, negative 1, 3, 3, 3/5, negative 3, 3/5, and 0, 6. Again, just by graphing that in the graphing calculator. So if I plot them, 1, 3, negative 1, 3, 3, 1, 2, 3, and negative 3, 3/5, and 0, 6, 1. And I did make a little video for you guys. So the domain will be negative to positive infinity. There's no restrictions as we move in the horizontal or the x directions. Now the range, I've done a little video. We need to find this max value. Now it looks like it should be 6, but I've done a little video, and I'll play this for you guys on how to find or calculate the exact maximum value in case it's not a whole number. I'm going to quickly show you guys how to graph one of these in the calculator and find a max or min. Sometimes it's not always going to be a whole number. It's not going to be really that easy to find. So the first thing you want to do whenever you're graphing, always go to y equals, clear anything that's out, or clear anything that's in there out of there. So, and then we're going to do 6 divided by x squared, and you can just use the square button, plus 1. And then we're going to go to graph. So this one's sort of like a bell shape, or it's got a curve to it. So you can sort of guesstimate where that max point is going to be, but that's where your range value is going to stop. So we need to know what that value is exactly. So if you go into calculate here, we have to do, it's a shift option, so we want to do second calc. That is a max value. So we're going to calculate what the max value is. So it'll say left bound. So you'll just want to go till you're just a little to the left of it, guess that value, then it'll say right bound. Scooch over, guess a little to the right, and then take your guess at about where it is. And then it will say maximum 0.6 is your coordinates. So in this case, it was an easy value to find, but it's not always the case. So whenever you're trying to find that max or min value, always do second, calculate, and then guess the left and right and take your final guess to get the exact value. So what that means then is that the range is going to go from 0, because that's the asymptote, that's the value that it's approaching, to 6. But here's the difference. Because 6 is a point on that function, it's part of your function, part of your graph, 6 needs to be included. So the lowest value it reaches or approaches, it doesn't actually touch or reach it, is going to be 0, approaches that value, and then goes up and ends at the actual value, y equals 6. So that will be your range. So for number 8, we've got y equals 2x squared divided by x squared minus 9. So again, for your x-intercepts, that's when you guys plug in 0 for y, and you end up solving for your numerator equals 0 when you multiply both of those sides by that denominator. So if we set 2x squared equal to 0, we would divide by 2, take the square and get 0, take the square root of 0 and still get 0. So in this case, there's one x-intercept and it's at 0, 0. That also means, guys, that if your x-intercept 0, 0, that's a point 0, 0. That means that's also going to be your y-intercept. There can be more than one x-intercept. That would be fine, and it's not that uncommon for that to happen, but in this case there is only one. Now for the vertical asymptotes, that's where you guys are solving for the denominator. So we would say, okay, x squared minus 9 equals 0, and you could either factor that and make it x minus 3 and x plus 3, or add the 9 over and take the square root. But it's going to be 3 and negative 3. So at positive 3 and negative 3. And then your horizontal asymptotes, that's where you guys look at your exponents. So we have x squared over x squared. So m equals n. So you divide those lead coefficients, 2 and the 1 that's in front of your x squared. So 2 over 1 is 2. So again, you guys can graph this in your graphing calculator to get the points. I know that 0, 0 will be a point because that's my x and y intercept. But if you do graph it, and remember, if you graph it, make sure the numerator and denominator are both in parentheses. So 0, 0, 4, 4.5. And I'm not point crazy, guys, but if you are using the calculator, you should be able to pull some points here. And 7, 2.5. There we go. So 4, 1, 2, 3, 4, 1, 2, 3, 4.5. And then -4, 1, 2, 3, 4, 1, 2, 3, 4.5. -7, 2.5. +7, 2.5. There we go. We can draw that in. And that in. Now, I should have gotten more points in the center here, but I will just draw that in as well. Again, it's just a rough graph. Now, you could calculate the max and min, or the max point for this value, or for this graph here. So the max would be this point here, but it is at 0, 0. So the range is going to go, remember, left to right, or bottom to top, least to greatest, in the y direction. So it will go from -infinity to that point of 0. And then the next place it starts, or where your graph shows up, is at 2, where that asymptote is. So it's going to get as close to 2 as possible, and then it's going to continue up. The domain is still going to go with those vertical asymptotes, guys. So because there's 2 asymptotes you need to use, there's 2 values we need to exclude here. So it'll go from -infinity to -3, skip that value. It's going to get as close to -3 as possible, but we are excluding it or skipping it. So the next section of your graph goes from -3 to +3. Skip it, and then 3 to +infinity. So 2 vertical asymptotes means 2 u's. 2 values we need to exclude or skip. And the last one, number 9, is a little weird, but that's okay. We'll do it together. So we've got x squared plus 3x minus 4 divided by x minus 2. So again, x-intercepts. We are going to solve for our numerator equaling 0. So we're going to say x squared plus 3x minus 4 equals 0. So I would factor that. X plus 4 and x minus 1. So my x-intercepts will be -4, 0, and 1, 0. So 1, 2, 3, 4, -4, and +1. Are my x-intercepts. My y-intercepts will just be whatever 0 squared plus 3 times 0 minus 4 over 0 minus 2 is. So we get -4 over -2, which is +2. So 0, 2. Okay, vertical asymptotes. That's where you set your denominator equal to 0. So x minus 2 equals 0. So you would be at +2 for the vertical. Now, I forgot, I'm going to hold off actually on plotting my points because I'm going to need to make a different scale. So we'll go back to the points. Horizontal asymptote, you're looking at your exponents. So we've got a squared over a linear. So 2 is greater than 1, which means when m is greater than n, there is no horizontal asymptote. Now, before I even graph this, guys, I know that my domain has to skip those vertical asymptotes. So this will be negative infinity to 2, union 2 to positive infinity. Now I'm going to graph it, and we're going to go from there. Graph number 9 here. Remember to put the numerator in parentheses and then denominator in parentheses. It does matter. So we've got x squared plus 3x minus 4, and that's all divided by x minus 2. We can go ahead and at least graph it so we sort of know what it looks like. And now what happens, guys, I know this obviously because I have the answer key in front of me, but you should have more than just one part of your graph. So if we zoom out here, go to zoom out, select that, and then actually do the zoom out. So hit enter twice. You can see now that there's 2 sections to this. So if we are trying to calculate the min and max, we can of course go to our table to get some points off of there. But if we're trying to find the min and max of each section so that we can find our range, we need to calculate that. So I'm going to do second, calculate. I'll do the max. So that's going to be the point of that bottom half first. And again, it'll ask for the left bound. It'll ask for the right bound. And then it asks you to guess, okay, approximately where do you think it is? And there it gives you x coordinates, -4 or -0.44 and positive 2.1 for your y value. So we could have zoomed in and out and sort of guessed, but the max value of that section in the bottom half is 2.1. Then if we go and calculate the min of that upper half, so you'll have to, if you guys keep scrolling over, you can't move up and down. If you scroll all the way over, it'll take you in between the 2 sections of the graph. So guess just to the left of that min value, and then just to the right, and then guess about where you think it is, and it will tell you 11.9. I'm going to round to 1 decimal place. Is the min value. So those 2 values is where your range is going to start and stop. So it's important that we get those exact decimals. So I'm going to do this graph by 2s. So let's see. We know that our intercepts are -4, 0, and 1, 0. So if it's by 2s right there and here, and then our y-intercept is at 2, 0. So I can go ahead and draw that section, and my vertical asymptote is at 2. And then some more points for 12. So 2, 4, 2, 4, 6, 8, 10, 12. I know 11.9 is the point, so just below 12, 2, 4, 6, 8, 10, 12. And then 6, 12 and a half. And just draw that in there. So it's again by 2s, but that's okay. So it is important, guys, to make sure you're finding these exact values if you need to when you're doing your graph. But again, the whole entire section is calculator. So if you have questions about using your calculator at any point, please just make sure you're asking me or someone around you that does know how to do it.